Okie doke, so this is going to be our review for Unit 2B. This is our study guide involving the second half of functions. So this is going to include everything from identifying linear equations, linear functions, to figuring out a line that fits a table and writing equations based on a line. So uh, just a reminder, do not be watching this unless you have already finished the study guide and are coming back to review, or if you are completely and totally stumped on the study guide and just really need extra help working through it. So here we go. Number one, the table shows a list of points in a linear equation, and it asks which linear equation has a graph that includes all of these points on the table. So for starters, the easiest way to go about this is pick 2 points that you're going to work with. I'm going to work with 0, 3, and I'll plug these into these equations down here and see if I can rule any of them out. So if x is 0, that basically goes away. So yes, -3, that checks out. 3 times 0 would equal 0, and no, 0.5 does not equal 3, or -3, so this one is out. Do the same here, times 0, that one would check out, would be -3, so it could be this one also. And then this one, we multiply 3 times 0, and that would equal 0. So -0.5, that will not work. So far, just by doing that one set of coordinates, this one, we were able to eliminate these two as answer choices. Now all we have to do is figure out, okay, am I multiplying x by 1/2 or -1/2 to have this work? Again, we're just going to plug in one set of values. I'm going to use this because 2, -2, whole numbers, it's always easier to work with whole numbers. For this one, we have 1/2 times x would equal 2. And, oh, that would be minus, not plus, so -3. So 1/2 times 2 would come out to be +1. +1 minus 3 does equal -2. So that checks out. For this one over here, I'm going to rewrite it all the way over here. We have -1/2 times x, which x is 2, minus 3. Multiply that. -1/2 times 2 would equal -1. And -1 minus 3 would equal -4. So this one did not work. The answer to number 1 should have been the first answer choice. We'll go ahead and select that. For number 2, it asks which linear equation matches this graph. So this is a straight line going side to side, so there is not going to be any slope. So this would just be y equals -3. We're not even going to say 0x for the slope because what would be the point? There won't be any slope. So y equals -3. There is no slope for this problem. For number 3, it asks what is the slope for a line that goes between point A and B? So we have change in x. We went from -3 to +2. To go from -3 to +2, we went up by 5 units. So that's +5 for down here. And the change in y, we went from 4 down to -7. So for this case, we went down. This one would be negative. So we have negative from 4 down to -7. That's going to be a change of 11. We would see if we could simplify this, but if you look at your answer choices, that matches the first answer choice perfectly. So for number 3, it would have been the very first answer choice. For number 4, this one gives us an equation, and it asks what would be the slope of this equation. So for starters, we would have had to rewrite this to be in its proper form. We need it to be in y equals mx plus b form, and right now it's not there. So we'll start just by subtracting 3x from both sides, just so that way we can get the x on the other side of the equation. And we are left with 9y equals 27 minus 3x. We're then going to go ahead and divide everything by 9, just to get the 9 out of there. And we are left with y equals 27 divided by 9 would equal 3. Negative 3 divided by 9, we could simplify that to be 1/3 of x. And we are going to go ahead and rearrange this, but you should be able to recognize from all the problems we've done that the slope is always going to be whatever is attached to that x. So we can see the slope should have been negative 1/3. If you weren't too sure about that, you could have rewritten this or reordered it. So that way we have y equals negative 1/3 x plus 3. Either way, no matter what you do, this right here would have been the slope, and it was negative 1/3. So that's going to be it for number 4. For number 5, very similar or exactly the same way that you would solve it. This one, we are going from 2 points, and we are just looking for the slope. So for the slope of this line, the change in x, we went from 9 to 4, so we went down. So 9 to 4, it looks like we went further to the left by 5 units, so decrease of 5. And then for the top, we went from positive 7 down to negative 3. So if we start at positive 7 and make our way down to negative 3, that would be a change in 10. So we went down by 10. Then we just see if we simplify this, because this is definitely not an answer choice. We have negative 10 divided by negative 5. Well, negative divided by a negative would equal a positive number, and this would come out to be positive 2 over 1, or just positive 2 for number 5. For number 6, this one was asking, what is the y-intercept in this equation? And we know in our equation, y equals mx plus b, we know that m is my slope and b is my y-intercept. And whether or not this symbol in front is a plus or minus tells us if it's positive or negative. So because this says plus 7, we know that the y-intercept for this equation is positive 7. Moving on to number 7. This one, again, it gives us a table, and it asks what function would line up well with this table. Once again, I'm just going to pick one that I would consider easy. My eyes immediately go to this one where x is 0, y must equal negative 4. So if x is 0, well, 2 times 0 would equal 0, so that's out. For this one, same problem. Negative 2 times 0, again, that equals 0, so that can't be it. These two could reasonably work, because 2 times 0 would equal 0, minus 4 does equal negative 4. Same thing happens to this one down here. So the next two problems I'm going to use would be x is 3 and y equals 2. So for this one, y would equal 2, and x would equal 3. And we would see, does this equation make sense? We have 2 times 3 minus 4, does that equal 2? Yes. 2 times 3 equals 6. 6 minus 4 equals 2, so that checks out. For this one down here, however, we would have 2 equals, that would be negative 2 times 3 minus 4. And this one has a different problem. Negative 2 times 3 would equal negative 6. Negative 6 minus 4, that should equal negative 10, not positive 2. So for number 7, the correct answer would have been the third answer choice. For number 8, this one is more of just identifying a pattern. See, if something is a function, then x and y should be moving at a constant pace. Meaning if x is going constantly down one at a time, y should be following some kind of pattern too. So we look at negative 21, something, negative 17, negative 15. You can fill in the blanks and kind of see this was decreasing or increasing by 2 at a time. So counting by 2s from negative 21, we would get negative 19 if we continued that pattern. And that's going to be our answer for number 8. So after that, we've got number 9. And number 9, it just shows a graph and it's asking what equation would work for this. So first of all, we're going to need our slope and we're going to need our y-intercept. Well, our y-intercept, where it crosses the y-axis, is just going to be at 0, 0. So the y-intercept is going to be 0. So already this part of the equation might not exist. As for the slope, it looks like we are going to the right by 1 and up by 1 every time. Well, that means my slope is going to be 1 over 1, which simplifies to just 1. So if I were to write a draft of my equation, I would have y equals 1x plus 0. Well, first of all, you don't really need to write plus 0. It's kind of ridiculous. And second of all, you don't need to write 1 times x. That's kind of ridiculous. All you need is y equals x. That's all we need for this equation. So that's what we're going to leave for number 9. For number 10, we have a linear equation to represent this graph. And this one is basically the next level up of the last problem. We have to first identify what our slope is and identify what our y-intercept is going to be. Y-intercept is going to be the easiest. Just looking at the y-axis, looks like we're crossing right about here at 4. So y equals, or b equals 4. The next thing we're going to need is our slope. And for slope, I'm just going to use this coordinate, and I'm going to see how the slope seems to be. It looks like we're going from like this point to this point. Excuse the distraction back here. It's nighttime, so he wants to play. So for number 10, our slope is going to be rise over run. So let's see, it looks like we increased by 3. So that's going to be my rise. And it looks like we moved over by only 1. So 3 over 1, which gives me my slope of just 3. So when I plug all this into my equation, y equals mx plus b, we've got y equals, replace my m with a 3, plus, that's going to be a 4. This should be the equation I am looking for, which is this one right down here. That's going to be it for number 10. For number 11, a student rides his bike to the grocery store, shops, and then returns home. The graph illustrates the distance the student is from home in relation to time, broken into 4 phases. We can see here, in phase 1, his distance from home is increasing quickly, while time is not increasing very quickly. So phase 1, he's moving pretty fast from home. He might be going downhill, he might just be in a rush. Phase 2, he's slowly increasing his distance from home. So maybe he got tired, slowing down, hopped off his bike to walk, who knows. Phase 3, his distance from home is not changing, so he's not moving any farther from home. And phase 4, he is steadily moving closer to home until he eventually gets back. And it's asking what best describes phase 3. Well, phase 3, he's no longer moving away from home at all. His distance is remaining constant. So A says that he arrives and shops at the grocery store. That would make sense because that would mean that he's not getting any farther from home, but he's also not getting any closer. So that makes sense. He decreases his bike speed. No, that's not really what's happening. He would still be moving farther away, albeit slower. The student returns home. No, that's kind of what happens way down here at the end. He rides his bike at a constant speed. Again, no, that explains why these are straight lines, but it doesn't explain why his distance from home isn't continuing to increase. For number 12, this one, it says, Juan observes a deer making its way across an open field. At first, the deer does not move. That's kind of important. So at first, the deer is not moving at all. Doesn't get any farther away, doesn't get closer. Then it starts walking at a steady pace. So starts walking, okay? Then it stops again. So it stops for a few moments, looks around. We don't really need that information. And then it continues in the same direction at the same pace, then stops again for a short time, and then takes off running. So if I were to graph this myself, I would say that at first, the deer is just not moving at all. Like that, it should be kind of a flat line at first. Then starts walking away at a steady pace, and then stops for a few minutes, so another flat line. Continues at the same pace, same direction, stops once again for a shorter time, and then takes off at full sprint. So something kind of sort of like that. So we should see a pause, increase, short pause, and then huge increase. Well, if we look at A, this one just has immediate increase. It doesn't show that the deer didn't move at first, so it can't be this one. For this one down here, it shows a pause, increase, short pause, and then big takeoff. That does match what we just kind of sketched. But let's just double check the rest just to be safe. C, it does not have that pause in the beginning, so that one is out. And for this one, it shows that the deer only paused once. But when we read that problem, it said that the deer didn't move, started moving, it paused once, started moving again, then paused one more time for a short period. So there should be two little steps, two little pauses that took place. And D just doesn't have that there. So my answer is B. For number 13, Anna and Kevin go shopping at the mall. They leave Kevin's house and stop at a gas station. While at the gas station, Anna sees a friend, stops to talk to him for a while. Next, they continue to the shopping mall. After some time picking out new clothes, they go back to Kevin's house. Okay, so which best represents their distance from Kevin's house? Okay, well, let's go ahead and get a graph ready. So just to kind of sketch this out so we kind of have an idea of what's going on. It says they're going shopping. They leave his house and go to a gas station. Okay, so they leave his house and then they're stopped. They're at a gas station. And she sees her friend and they stop and talk. So kind of a long pause. Next, they continue to the shopping mall. Okay, so they continue there, go to the shopping mall. They spend some time picking out new clothes and then go all the way back to Kevin's house. So this is kind of sort of how the graph should look. They go about part way to the mall, pause, get the rest of the way to the mall, pause, and then they return. So A doesn't quite match. For some reason, they never quite make it back to the house. This one looks like they stop back at the gas station again. For this one, it doesn't show the pause at the gas station. It shows them going halfway, and then it just shows them going quicker from there to the rest of the way to the mall. So it's not B. C does show the pause, and it shows the pause at the mall. Let's just double check D, make sure it doesn't work as well. No, D does not show them staying at the mall to shop at all. It shows that they got to the mall was closed, and they turned around and went home. So C is the answer choice we want. For number 14, it says Celine used the function table to make a graph. And it's saying which graph shape shows the connecting points in the table. So let's go ahead and just draw a rough sketch really quick of our graph. We don't have to make this exact, but we do need to see where certain points are supposed to be. So if I were to draw this graph out, when x is -5, y is -5. So 5 to the left, 5 down. Doesn't have to be exact, but that's about where one of the points are. -3, -3. Again, 3 to the left, 3 down. So something like that. 0, 0. Well, that's dead center of the graph. Okay. 3, 3. Okay. 3 to the right and 3 up. All right. And 5, 5. That's going to be 5 to the right and 5 up. So obviously this is not exact, but it does give us enough of the information to make a choice. Is this going to be a symmetrical V shape? No, this is not a V shape at all. This is just a straight line. or straight enough. So it's not a V shape at all. It can't be those two. It slopes up from left to right. Yeah, looking at it from left to right, this is sloping upward. So that's going to be our answer choice. For number 15, this one going back to a crazy thing. When you guys read this, there won't be a typo. It will say the graph shows the speed of a car during a 60-minute period. According to the graph, what scenario could be happening to the car at 20 minutes? So at 20 minutes, we can see that we are at 20 minutes and our speed is 0. Our speed is completely at 0. So does this mean the car is accelerating? No, the car is not accelerating at all, nor is it driving at all. The car is at a dead stop. The speed, this part right here, this axis, is right here. It is lined up with 0 miles per hour. That car has stopped and is not moving. So we want D. For number 16, this one shows, well, it shows a couple things. It shows a graph. So this graph, it is not linear. It's not a straight line. That's the definition of a linear function, is that it is a perfectly straight line. So we already know nonlinear. So students are asked to write 2 words to describe the graph between x equals -1 and x equals 4. So between x equals 1.5, I just drew it at 1. Between 1.5, which is here, and 4, which is here. So students have to describe what is happening between those 2 red bars I just drew. And let's see. Colby says that it is linear and increasing. Colby is wrong on both accounts. This is not a straight line, nor is it going up. So no. Melanie is at least closer. It is decreasing, but it is not linear. Royce, again, they're close, but no. It's non-linear, but it is not increasing. Victoria is the one who is correct. The line is nonlinear and it is decreasing. For number 17, a weather station recorded a variation in temperature during a 20-hour time frame, and the findings are shown in the graph below. Okay, so it looks like it decreases, increases again, and then it increases very, very quickly, and then it decreases slower again. Okay, so let's see which statement best interprets the information provided in this graph. Option A, it says that the temperature rises at a constant rate the entire time. No. If it was constant, we'd see one straight line and that's it. This line makes a bunch of turns, so no. It rises at a constant rate between 0 and 8 hours. So here's 0 and here's 8. That is not a straight line, so no, it is not a constant rate between those 2 periods. So that's out. Next up, it is asking us, the temperature falls at a faster rate between 16 and 20. Okay, so it's saying that it's falling in this time period faster than it falls from 0 and 4. So here's 0, and here's 4. So are these decreases, are one of these steeper? Are one of these a quicker or slower increase than the other? No. Both of them are going over by 1 and down 1. They both have the same slope between those 2 sets of red bars. So it's not going to be that one. That means the answer has to be down here. It's got to be that the temperature rises faster between 8 and 12. So let's see. Between 8 and 12, it says that it is rising faster between those bars than it was between 4 and 8. And that is true. It is considerably steeper in this second section than this first section. So that does check out. So let's clear that. And what are we at? The last 3 problems. So Consider the line shown in this coordinate grid, and it asks what best describe the slope of this line. So the slope, it's moving in a straight line, so it's linear. It is going up from left to right, so that makes it positive. If it was negative, then the line would be moving more in this direction. If the slope was 0, it would be a perfectly straight horizontal line. Undefined, it would be a perfectly straight vertical line going up and down. Last two problems, it's asking for what equation would best fit these 2 points. So we need to find the slope, and we will need to find the y-intercept. So for starters, we're to find the slope. We are going to go from, let's see, 0 to -8, which that's the change in x. So the change in x there, the run, looks like we went down by 8. So -8 for the bottom. And then for this, we went from -4 to +0. So this one, we increased by 4, so +4. So +4 over -8, that would simplify to -1/2. So my slope is -1/2. So y equals mx plus b. We now know that y equals, it would be -1/2 x plus something. We don't know what that something is yet, but we can rule out these two answer choices. You know, it's either going to be -4 or -8. So I'm just going to go ahead and pick and plug in this value right here. So let's see, y, that's -4, equals -1/2 x, x in this case is 0, plus b. So naturally, -1/2 times 0 just equals 0, so this is effectively gone. And we are left with -4 equals b. So there we go. -4 would equal b, which means my equation should be y equals -1/2 x minus 4. And that's it. That's what we get. The final problem is exactly the same, only this one, it gives us a graph and 2 points. Now, you can do this algebraically with the way we did number 19. Or you could do this graphically. You can look at it on the graph. We can see the y-intercept right here. The y-intercept is going to be a +3. And frankly, me just saying that kind of gives away the answer choice. Because if my equation is y equals mx plus b, and b is my y-intercept, well, if I can see the y-intercept is +3, what's the only answer choice that has this? The fourth one. Nothing else would even work. So I just saved myself a whole bunch of trouble just by paying attention and seeing what the y-intercept was. And that's kind of the beauty with this unit. As much of a pain in the butt as all the Delta math assignments were and those worksheets were, the actual problems themselves, if you at least have a fundamental idea of what you're looking for the most part, you can rule out answers before you even begin a problem. A lot of these, you can cut your answer choices in half right from the start, and the rest of them, because there are answer choices to go off of, you don't have to risk working on a problem for 10, 15 minutes, not coming up with an answer, because you can at least work things out slowly and slowly. And little secret, if you are really 100% stuck, theoretically, you could solve this problem the same way we solved that table earlier in number 1. You could just start plugging in these values to each of these equations and see which one works. So that could totally work. And that's going to be it. I do have one last bit of information since tomorrow, or not tomorrow, tomorrow's Veterans Day, but on Friday when we take the unit exam, just a reminder, the unit tests are perform level assignments. Those are the ones that are 50% of your grade. Those assignments, you do still have unlimited retests. So if you don't do that well on this one, if you don't get a super good grade that you're happy about, you can redo this one a lot. Unlike the quizzes, those only get one extra attempt in some cases. But let's just go ahead and submit this, make sure that I don't have any typos. Let me make sure that nothing was wrong. Nope, 20 out of 20. So that is going to be it for the study guide. I hope it helps. My advice would be to do this once on Wednesday, once when we're actually doing this, and then maybe pull it up once more Friday during tutorial, so that way it's kind of fresh in your mind the same morning that we have the test. But any case, good luck, and I'll see you guys later.